Okay. All right, so we are on camera. We're being recorded. Keep it clean. It's mostly for me. Minor, rather than equals. Let me get this. Let's continue. Are we on time? I'm gonna give everyone like just a couple minutes in case we get more stragglers, but good turnout, guys. Thank you. Now you have a lot of options for flying with us. Appreciate you being here today, but I think there's like 5 tracks going on at the same time, so super cool. If you guys don't know, we have Lockpicking Village. What's up, Billy? Hey, what's up, man? We have Lockpicking Village downstairs. Some cool locks down there, but I'll be there for the rest of the day in case you guys want to get hands on. After getting all amped up after our bundle talk here. How was the keynote? Yeah. Any like upcoming cutting edge topics that we're going over? Or just like intro to Southwest Florida hackings?
There was a theme was around a digital immune system, with kind of like automated remediation for different types of threats.
Automated remediation, so like AI.
Not necessarily, a lot of it could have been, I guess, rules based, just a whole data, good data science, statistical analysis, threshold, and
Solid. Okay,
sure,
sure.
correct.
Yeah. Sorry, I'm super something for the. Where are you guys at with physical security? Has anybody done it before? You guys familiar with lockpicking? Yeah. Well, physical security kicking people out or breaking people in places?
I would say I know like OCP, COs, HID stuff.
Okay, all right, so like RFID.
RFID, I work, not as I work, but I provide physical security to the state.
Okay, so like on the blue team side,
Well,
like
like in fact,
you learn homing, how into that stuff. True.
I know Vigilon, that says anything, I know Genetech, I know Access, I know other.
All right, I'm gonna call on you. We'll go through those slides. And you did some good stuff back there too? Yeah.
For Lee Health.
Okay.
I'm part of the cybersecurity department now, but I also work with security department for physical security. Edges,
Yeah.
locks, access.
Cool. Do you think you could break into that place or you guys kind of locked down?
It's pretty locked down, but because I know the system,
Yeah.
I could probably get created.
That's it. No, it's a really good point though. Understanding things so well, the infinity, like it's RTFM, same deal as hacking. Once you understand those systems thoroughly, it's a lot easier to find out the holes to be able to use them in ways they're not supposed to be used. I think we're about on time, so we'll start going into it. I'm so sorry to this. It's a really long talk. We have 15 minutes. I don't think there's anything in here after, so maybe we can go over it a little bit. But if there's time for FAQ, that'd be great. But I revamped this slide deck, so it's brand new. It's better than ever. And I tried to pare it down a little way at the slides. And we're up to 86, I think, for our 50-minute talk. So God bless us all. All right, so we're going over physical security today. My name is Justin Wynn. I've been a career penetration tester for about a decade now. I used to work at Coalfire that I just left last month, but that's pretty much been the entire extent of my career in the industry. Throughout that time, I started as probably the greenest associate that we've ever had. Worked my way up to consultant, to senior, to principal, and eventually I was director of the red team, leading anywhere between 8 and 15 individuals on all the cool offensive work. The majority of this is network-based. We're doing web application penetration testing, network, Wi-Fi, mobile, AI, any attack surface that exists out there. That's what we were doing. My subject matter of expertise was physical security, so that's anytime those engagements came up, either heavily involved with running them or going out on site and actually breaking into places, which has just been my passion and what a blessing for me over the last decade. Red Team Alliance does a lot of the courses, certifications down here that you see on this line. Highly recommend them. I've done probably every one that they have that's relevant for my field, and it really steers in the right direction. Is anybody familiar with Iowa courthouse break-ins that occurred around 2019 where 2 pen testers got arrested? Yeah, some people heard of that. That was me. We're getting a little dated, long in the tooth now. It's been 6 years. We were wrongfully arrested, going on site, hired by the state of Iowa to break into courthouses. A local sheriff who had beef about jurisdiction decided to arrest us despite knowing that we were there on site, working on behalf of the state to improve security. So a bit of an oversight there, but just want to set the record straight because once we got arrested, they had control of the media spotlight. Our lawyer advised us, hey, just remain quiet. So a lot of the articles out there say, oh, there were scope concerns, mismatch here and there. None of that came up. The man arrested us because this is the county's courthouse. They feel pretty stupid now, don't you, boy? Pretty much verbatim quotes. Okay. Last year I went on the circuit. I've keynoted conferences before. I've spoken. Last year I did 8 talks around the world, I think. So again, super cool opportunities there that I'm very grateful for. And I'm currently writing the book on covert entry for No Starch Press. You guys are familiar with them. That's pretty much our publisher inside the industry. Super cool people. Bill Pollock approached me after being on stage one time. Just wonderful people. So always like to push and support the people that are supporting us. So like I said, agenda, I did a terrible job producing the slide deck, 6 slides, 50 minutes. I'm a fast talker, can't really slow this down. If you can understand, let me know. But this is pretty much what we're going over today. You may notice something is missing, that's lock picking, because we have a wonderful lock picking village downstairs. I'm happy to go in deeper on that later. Okay. As a quick overview, because a lot of this is going to come up and be relevant for our talk, we need to go over terminology. This helps us keep on track, make sure we're synced up, talking the same language. We'll be very specific and tactile about what we're trying to communicate. So this is, anybody know what this is? I'm going to lock silver. It's a lock. Yeah. Good job, guys. Man, you're in the right place. Okay. So on the outside, we have the shell. This is in green. That can also be called the lock body. Inside, there is a cylinder or a plug. These are 2 independently milled pieces of metal that, without any other components in play, would be able to freely rotate. So the reason that you can't just go up to the lock and rotate it with a pocket knife or a screwdriver are these pesky things called pins. In this one, we have 5 pin stacks comprised of a spring that pushes down on the driver pin, which drives the key pin. Okay. So that's the internal terminology for a pentameter lock. The system has been in use for literally thousands of years. They have artifacts dating from 4000 BC Mesopotamia, using this identical mechanism, just using wooden pieces rather than machine spring. Okay, door hardware, a couple key components here that I want to go over. Deadbolt, a lot of this is in the name, auxiliary dead latch, and then latch bolt. We're going to go into these components later. Some of these dead and some of these, to maintain the function of the door, need to be able to retract and then stay locked. We're going to go into how that works deeply. And this other conjoining component with this is called the strike plate, which is comprised. Yeah. Technologies, how smart it is. Oh, we're going way too far backwards. Okay. There's about 1,000 clicks happening. We're being hacked, which is actually talking a terrible night's sleep last night. My buddy just got compromised yesterday, so we're doing hacking triaging on that. But cool, because it's not like my job, but we're all adjacent. I'm sure you guys all get those calls, or usually it's like printer help with your own phone or some worst part of this industry. All right, padlocks. Same deal. We're gonna have a body always. You have a shackle actually remains closed, goes around what you're trying to protect. The plug inside, and then springs. Kind of the most important part here I want to go into are the latches for locking balls. This is what actually engages, invites into the shackle to keep that closed. We're going to learn how to defeat that. But before we do, we want to go into the legality of carrying pits. This just came up downstairs. Somebody was talking about a buddy who was cutting through a field and had a set of the Kevin Mitnick cards in his wallet and got popped. And then obviously that comes up in a question. In Florida, we are pretty open about lockpicks. Unless you are actively using them, then they become part of the burglary tools, which I can tell you in Iowa carries a sentence of 2 years. Florida, I don't know, and I don't intend to find out. We're pretty green and golden across the board. There are a couple of states that are more restricted. What may be most relevant for us is some of the hazard conferences that take place out in Las Vegas, right? DEFCON, Black Hat. That state is prima facie, which basically means you are guilty until proven innocent. I fly there every year. They sell lockpicks there at the conventions, never have issues. I get questions sometimes. I'm a locksmith. End of the conversation. Depends on your agent, because TSA is one of my favorites. But even on their website, they do have this blurb out here that lockpicks are okay. This came about as a result of tools working with them, kind of hounding them like, hey, we're always getting asked at the airport. I understand it's like kind of a security thing. But if you guys can put something on your site that explicitly states so your agents are all kind of aligned, we do have that. So if you ever do run into issues, that's on their website. Hopping right into that padlock bypassing, it's called shimming. This is a video made by Master Lock, and they differentiate two different techniques. Usually I can join the two, but this one is called rotational shimming, where they come down behind the locking ball on the opposite side and then rotate around into it, depressing the locking ball. This is top-down shimming. You have an angled edge that pushes against the beveled edge. The mechanical principle of an inclined plane retracts that locking ball. To use this, we use padlock shims. They come in various sizes, so the different colors here by bro gauge denote that you have small, medium, large, maybe like an extra small. Some of the padlocks do have locking paws on either side, so you need to retract both sides. Otherwise, one is still biting the shackle, lock's not going to open. This one is already engaged, so this would be kind of like the top-down method where if you push that down further, you start retracting that ball. But if you were on the other side, you come down, and usually you do need to go behind it so you can get that room and wiggle in, and then start finessing and rotating that around. Get hands on with this stuff. It's really the only way to learn. I'm going to introduce you to a lot of concepts here today. We are scratching the surface, and there's not a whole lot of technique behind this. So you guys need to get into the field, get hands on with this stuff, and start learning that process. But this is just to kind of ignite things, to wet the whistle, get us interested in crime on a lot of these physical security concepts. The worst part about padlock shims was carrying them. So when I was kind of like a novice in the industry going out on site, you run up to a door and you get down there, hands and knees, you got a padlock here, you try to pull them out of your pocket, and things explode. You got like 12 different shims hanging out, lock picks, all that sort of stuff, which I combined into a small little profile that I came up with a terrible name, 6-slot shim sheath, that I try not to say too often. But it's really cool because it does compile all my shims, bow top picks, and then two different types of bypass tools there. We'll even know what both of those are used to. But super handy concept to just get things neat and clean. Available on my GitHub if you guys are interested. Nowadays, I don't tend to use padlock shimming too much in the field. Picks generally get you through, but still, I mean, there's a time and place for it, so it's a good tool to have in your arsenal. If you do want to have something on you 24/7, so you're able to bypass these, again, you don't want this triangular piece of metal. You can't really carry that. Too easy profile sucks. So what you can do is cut out a piece of aluminum from a metal can, shape it out as this can, you draw the grid on it, cut through, shape it up, round it around a ballpoint pen. Once you insert the lock, that's able to get you around that mechanism. So there is remediation for this. This problem is completely fixed using ball bearings. So rather than being able to shim down and retract those lashes directly, these ball bearings mechanically cannot move because there's an interior mechanism called a cam. And figure 8 cam, here we go again, where you have a cam mechanism that has two indents.
You have a hand gesture sensor above the
How do
board,
we sticky note that? Which one is that?
that big white bar.
Okay. All right, we'll figure it out. We're gonna struggle through this together. I don't understand why it keeps going like 10 minutes later, though. Maybe it will help us get through this deck. It's just gonna do its thing for a second. Okay. No spoilers. I'm trying to see if there's like other buttons here where I can turn that off. It is going nuts.
Then just be unplugged.
Emergency ripcords, you know the easiest way.
All right. Okay, so we're halfway done. Okay. Problem's completely solved. They have ball bearings that can introduce in this mechanism. Mechanically, there's no way to go until this rotates. And then there's the indent for the ball bearings to fall into, shackle can be released. This is kind of the case with a lot of those security things that are just so cheaply mass produced. And there is a time and a place for it. Sometimes we use locks as a seal, not really for security, but as a legal barrier, things like that. But there always are higher security options. We even have some allegedly paint-proof locks that have been on the market. They just get like financially unreasonable to use in market installations. So there are some reasons we don't use them. But for padlocks, how cheap and quick and easy they are, there's pretty much not an excuse not to use ball bearings. So it's one thing I'll look for if you are trying to secure anything of value. If it's your luggage or something like that that already has the TSA override, maybe you're fine just using a lower security mechanism. But that's what it looks like on the inside. Also, ironically, through Master Lock, I used to crap on them a couple times throughout this presentation in the past. But they've done some nice things for the industry. One was that first shimming video, they did create that. They created some nicer locks like we just saw. Unfortunately, they do have a history of litigation against lock researchers. So if you could come up with an exploit against one of their locks and try to disclose it to them responsibly so they can fix things, they'd rather just slap you with a cease and desist or threaten legal action rather than make secure locks. So that's why I'm not the biggest fan of them. All right, so we have another mechanism that we can bypass some of these locks with. Not everything's vulnerable to this, but if we can bypass that key authentication, we can reach directly back into the internal component. So it's like bypassing the login screen, just about for this in cybersecurity terms. And some of these locks are vulnerable. So you have American 700s, 1100s, a lot of the Avises are vulnerable to this using drivers. And I have a quick video for you.
It's all lined up like this. Peterson tool simply fits into the keyway. You jiggle it a little bit and then it's fit up against the cam. And it will turn. You get the idea. It'll rotate.
So it's like a little golf club. If you remember, these are pin chambers. We have bypassed that entirely. We're going just to the mechanism that should only rotate once this is rotated. But using that tool, we can start manipulating that stuff. You shouldn't have access to that. A lot of the stuff about physical security is about tool insertion or access, mitigating those gaps. And anytime we can reach a component into the more trusted side of things, that's where vulnerabilities are exposed. So taking a look at this a little bit further in
We
action.
want to insert our bypass tool again at the bottom of the keyway. We're just gonna slide it in there. And then we'll turn this sideways so you can see. Now what we have to do is work our way, just gently flick it back and forth to find that little hole and to work the tip of that bypass tool to it. And you should hear a little click. And when you do hear the click, then it's like a key. You get a little spring motion on the tool itself. Then we turn it. Bam, there we go.
So a couple things to note there. He had his bypass driver. The tip of that's called a flag. The flag pointed away from the key pins in this. So that's specific to the American locks. On the Avis locks, you want to go with the flag facing them. They have different drivers for different locks. One's pretty universal. They're most of the same size, but you are having to snake this through a little hole in the back of the mechanism. That's where I can't say you struggle, but it takes a little time to find that, manipulate, and push through. I found on American 1100s that takes actually quite a bit of force to push that through. So it's getting familiar with your tools, getting hands-on, learning things. I actually broke one just before this talk. So always still learning and experimenting where the tolerances are in line. So it is an expensive hobby to be able to acquire all this stuff and then be able to break it well. But this is fixed too. So American came out, they had just hundreds of these locks, thousands in the field, and just they would go under if they had to recall all these, right? So they came out with a field expedient mechanism. So they came out with this restriction plate or bypass wafer that basically sits over the rear of the keyway and prevents tools from being able to reach towards the back. So with that in play, highlighted in the red call out box, the silver piece in the middle, that's actually his flag pushing up against that plate, and now we can't reach that. But it's always a cat and mouse game. You guys are probably familiar if you do cybersecurity. Anytime an attack comes out, there's a defense, and then there's a workaround for that attack. That is called a wafer breaker, and this is used to punch through that little thin wafer and then still get you access. All right, so there are other keyway bypasses, and pretty much everything just revolves around bypassing the authentication, extending beyond that, and interacting with components that you shouldn't be able to access. This is the silver bullet, I think made by Sparrows. There's a couple manufacturers for it. Same concept. This is going to reach through and start interacting and pulling on things. What this does on Master Lock 1 through 4, you can retract both pulls mechanically through the keyway. It's kind of like shimming. And then on 5 and 6, it actually enables shimming by giving you a little bit more room, but will not bypass it on its own. We also have overlifting attacks. And a nice little animation to show this. So rather than having to pick a lock and meet the shear line, what a cone does, if you have a large enough Bible, which is the large part that contains the pin stacks, you can actually overlift not just the driver pin, but the key pin as well, and basically make a second shear line underneath all the stacks of pins. So with that cone, you can overlift. You can identify this on a lot of locks. Due to their wide body, it is a necessary factor in this where the Bible extends so much. You can still have large bodies where it isn't that deep on the inside, where they're still resting where they should. You're probably familiar with this one, the Master Lock 141, its brass brother. These are the tools that you use to bypass them. Typically, you're gonna see 4 pins and locks like these. We go up to about 6 usually. Some of these homes are Chinese, so for different purposes, you'll get them on Alibaba, and they may fit locks that we don't see here too often. The important component here is the teeth, the sizing, the spacing, so that's why you may still see, one that has 5 on both sides, but it's slightly different to be able to fit different locks. That's specific to the manufacturer, how they space and set up their pin stacks, so you just have to be prepared for all those situations. All right, this is a really cool one too. Match Lock 151, guaranteed you've seen this everywhere. Maybe you haven't been paying attention or looking for it, but after this, I guarantee it will start popping out to you. This is the most ubiquitous combo wheel lock that we have in North America, and it is atrociously easy.
How these things operate is pretty simple. You take the pressure, push in on the shackle, take the pressure off. These lever here just lifts up, and that's all that's holding this in place. Right? Quickly lift up on that, shackle comes open.
So again, really being able to understand things, we can take them apart and understand what's happening inside the lock, then we have a much better chance of being able to defeat it, seeing where the security mechanisms are or aren't. In this one, there aren't too many, but again, it comes down to the tool of mitigating tool insertion, which they've done a better job of nowadays. We'll go into that in the next slide. But these are some tools that you can use to bypass this. These come in 2 different thicknesses. One is called an easy decoder. One is quick stick, which is actually the bypass tool. Bypass tool is a little bit thicker, provides you a little bit more strength to be able to push through and lift up on this. The tips that I have for this one, when you're trying to insert and get this into the wheel, first of all, you have to go in between wheels 2 and 3. If you go on the outside, there's some additional security mechanisms that try to prevent your tool insertion. But these tools are so thin and flimsy on that x-axis. I mean, they're stronger against the wall when you're pushing like that way, but you have more resistance. But left and right, you got nothing. So what I try to do is pinch the tip and you guide that in so it doesn't have much wiggle room to be able to flex and bend. Preserves the life of your tools a little bit longer. The other thing you can do when you're using tools like this, especially on padlocks, you want to depress the tension on that shackle. So you press that, take the spring weight off of it, and it's a little bit easier on your tools. Nowadays, on the right, they're coming out with higher tolerances on this. So this is one of the original models you can see from maybe a decade ago. Tool insertion opportunities all over the place. I mean, wider wheels, and you can see here, they really lock things down. This is still exploitable. It takes a lot more finesse. It's still the same concepts. There's more about angling and understanding what's on the inside and how to circumvent it. There are some great videos out there. I try to do shout outs on all the screenshots that I remember where they came from. If not, you see this video afterwards, feel free to holler at me and I'll give you a proper shout out. Combo wheel decoding. So the way these work, there's called gates, and this is similar on safes, but imagine you have a wheel and there's going to be a cutout. It's a gate on that. And you have 3 of those wheels that can be any which direction until you align them properly. Now you have 3 gates in a row, and whatever the mechanism is, now it can move in. There's further travel where 1 gate out of line, the interior locking mechanism is not going to be able to pass through and give you the clearance that you need. So you can go through and enumerate gates like these. So on the sides of the wheels, you should see channels. So there's the axle they all have to revolve around, but when they're lined up properly, they present that gate to the interior locking mechanism. You can go through with decoding wheels, with the easy decoder, or I think that's Southward who makes these with a little notch. There are some pretty cool techniques. So rather than, you're gonna have to place this in there, and it's pretty easy to get it inside the wheel and you rest it. And then rather than, kind of rotating away from you and like feeling like where it bumps along, it's a lot easier to identify that gate if you rotate towards your tool. So this is coming in and then boom, like you get snagged, or you'll bend your tool and you keep trying to rotate that further. That's about the best mechanism I found to be able to identify where those gates are. You can also visually decode these, which is really common on a lot of combo wheel locks. They're just cheap, $5, $10. Those tolerances are so loose, you can slide the wheel out of the way. Once you know what you're looking for, these are identified. Lighting is super helpful. Magnification can go a long ways for you, so all good things to have in your kit as well. This is a video by Deegan. It's not a video, it's just a picture representation of YouTube, but he goes into 30 minutes of how you decode these, low and slow, all the best techniques in the world, probably using a Peterson knife here, which is one of the better tools to be able to attack combo wheel locks, and that's just like a generic realtor 4-wheel combo box by most likely Matchlock that we see all over the place as well. But again, just trying to provide you seeds, plant those threads for you guys to go up and look at these later. Next vulnerability class we're going to talk about are key-alike systems. These are locks that basically all open to the same key. So you may have one key for a municipality. USPS is a great example of this with their arrow key. They have one lock coded for a zip code, a county, a city sometimes, and it's going to open all the mailboxes in that location. So there are very valid purposes for this. One key can open many. Then you can pass that out to other people. Maybe you have construction workers trying to get in the building, and then they can have one key that can operate all the locks if they're key alike. This can also come about in some nefarious ways. Obviously, if that key gets leaked, then everyone has access to it. People may sell these unwittingly. Locksmiths may just assemble 100 locks keyed alike and sell them out, and people may end up with the same lock. Keys only have certain amount of biddings. Usually, it's very significant. You can have all the randomness that you need for most installations, but still keys will overlap. And just common manufacturers, for cabinets or low security grade things, can put out these locks and just have 1,000 of these ready to go. And then maybe from different cabinet manufacturers still have the same key. So you will see this all over the place. We're going to go into some examples, but some of my favorites are seeing this on ATM machines, on election machines. Has anybody seen that image before here at the bottom of those keys? If you're up front, you can read TSA. This was a leak. So this is our TSA, our lovely TSA locks, that government agency that's just always doing so much for us. I'm pretty sure you can campaign for presidency just on abolishing TSA because I work for that Singlish voter. But a report went through, found the keys, was talking to TSA, they snapped the images, post them online, and that's your password, ladies and gentlemen. So always get a good shout when somebody posts on social media and just bought a new house. Bought a new car. It's a little bit less risky because they're the RFID component as well. But yeah, all the things you may see this on. So vehicle fleets can be key alike. 1284X key is notorious for that. In New York City, all the police cruisers use that for a while, or most in certain departments. Taxi cabs, same deal. Devon has a great story where I think they were arresting like a cabbie and they lost their key for the cruise. It's like, oh, you just use mine because he had the same 1284X key was used for all the taxis as the police vehicles were, and the police were a bit confounded by that. Like, how do you have the police car key? Construction equipment and all the big heavy machinery pretty much uses identical keys across that model. So we can use this in physical penetration testing in a number of ways. We typically leverage a lot of life safety systems. So when you have the hierarchy of what's important when you're constructing a building, life safety typically takes priority, like in most, like outside of military, nuclear installations. We prioritize letting people out of the building if it's on fire, rather than failing and everything locking down. So also emergency ingress for personnel, fire departments can carry keys. Most notoriously is the FEOK1. What is the most ubiquitous fire key? There's whole rings of these. I mean, maybe there's 50 out there, but you'll see them pretty commonly on elevators, and you can override that system. So even if it has access control, like RFID, life safety still has priority. They need to be able to come in here and be able to access this elevator without having to fuss with credentials and get up to the floor they need so they can save a life, put out a fire, what have you. As security professionals, we can leverage some of these mechanisms and take advantage of that to accomplish our security needs. That's done nefariously, so we need to do it benevolently as well. Key-like systems and construction systems, these are construction cores. These are kind of hard to pick up if you've never seen them before, and then once you know they exist, like they just glare out to you. I mean, it's a different color in the keyway, so you'll see stuff like that out there. But once you start looking for this, it's really interesting, the places that you'll see this stuff left. Why does it happen? Again, it's cheap. Somebody may not understand the implications of this and has an entire box of these and just throws them around. But there is one set of keys for these. It's technically two, and we'll go into what that looks like because these are really cool, unique locks that are called SFIC or LFIC. Small format, interchangeable core, large format. Really complex mechanism, but what it does, it allows two keys to operate this lock. One is the operating key and one is the control key. You would give the end user the operating key so they're able to come up, unlock the door. Don't know how that works. The operating key, what that does, or the control key rather, sorry, allows you to remove the cord. So this is fantastic for Multi-unit residences, tenants, you can come up and have an entire building, with different locks in there, somebody rotates out, you can just pull out all the doors, swap out new ones into there, so. Previous keys don't work for that location anymore, saves a ton of money, and it's just really field expedient. Once that core is removed, it's gonna leave a cavity like this, and here at the bottom, you can kind of see, the two prongs poking out, almost looks like a tuning fork. That's the cam mechanism, so when the lock, is operated properly, it rotates that to be able to open, the latch. And to do that, to artificially simulate that, if we had or the control key, and we pull that out, or if we take this to the control line and we remove the core rather than open the door like we were going to. Highly recommend using a tool like this that bites onto both those teeth and rotates them. It's a little bit harder to use pliers in there. You run the risk of, damaging some things on a client site, which we generally try to avoid. So this is really cool for us locally. I like having a local conference. This door on the left, anybody familiar with the Nike missile sites scattered throughout the Everglades? Yeah. Super cool, man. This was done back in like the 70s, Cold War era. We had surface to air. And they actually did quite a few things, like surface to surface that I didn't know about. We actually had nukes in the Everglades for a while. It was like 4 years there where we had that. This door here is to the hangar where they carried the nukes. And it has a construction board on the outside, obviously decommissioned, but still it's a fun land. Former headquarters, it was on another floor, they didn't have a tenant in it, but it's just funny to go around, you see like, a secure building, and then this one didn't have the core in it at all, so straight up, you don't have to remove anything yet, you can just go in there and start rotating that to retract the latch. This has further implications for telephony-based access control systems. You guys may have seen these call boxes outside apartments. You can see this in like a multi-tenant office building as well, where you have different suites and you need to buzz your person and let you in. So you can do your social engineering attacks. There's multiple ways to get around things like that. But these boxes are all key to wipe. So linear boxes use the 222343 key. DKS door king systems use the 16120 key. It helps be able to enumerate and profile these, get the key out of your pocket, ready to go, take over your shoulder, make sure nobody's watching. But from a distance, you can identify what you're going to need. The AZ call buttons are really unique to the DKS systems, whereas linear pretty notorious for having both their speaker outputs, where they place their keypads, how they're lit. So there's unique identifiers. So you can start getting geared up before you're right there in front of it and need to act quickly, because as quick as the bypass is, you don't want to be fumbling with keys while you're out there. It's going to roll up on you. But to show you how you can use this in the field, we have Deacon.
Don't be running so late.
Turn off the lights. Oh, turn off the
Well, let's try.
I'll replay and I'll talk a little bit too. He's a little quiet and this sort of video's quiet. So you're saying we have a locked door, which is phenomenal because you never see that. Somebody goes up and actually tests that the door is locked first. That's the first thing you need to be doing when you're trying to get in a place. You don't want to go up to the door and try to immediately start picking it and then find out that you locked the door. That's never a good time. So he's talking about various things you can attack here. They have RFID, the mail goes by, but if you pop that open and hit the relay manually, just unlock it that way. And you're in. It's funny, a lot of the exploits that we use to be easier or quicker than using the key or entering the combination. So we were rolling through a bank one time and we're doing the debrief and they called us up and they're like, hey, we're watching the footage and you guys just blowing through like all of our, did they not lock up that night? Like what happened? Like, no, I mean, it was everything was locked. We just used our bypass tool, slipping latches, and it's like just opening the door. You get good at it. That's it. And we'll go into that too, because that's like probably the number one most common bypass that we use. So further, really just hammering on linear systems. This is Dennis Maldonado. Did a lot of research in these, like 2014, time flies, but found some other visible exploits, not only like network and stuff you can do remotely, we can also attack the keypad. There's default credentials in these, which are changed maybe half the time. You can disable it at this interface, so you can only do it from the back end. But legitimately about half the time, even to legitimate offices, places that have security concerns, you do not see this change. And here's the exploit for that. Okay, he's done. Enter the code, access granted. So what he did there, he grew just 0 and 2. That's let me into the admin interface. Enter in the default combination 1 through 6. Pound to enter. Pounds are enter keys on things like alarm systems or telephony-based access control. He understands the menu, so there's different functionality once you have authenticated to it. The combination 31 lets you add a user, prompts you for a code to add twice, which he did, and then 99 pound backs you out of the admin menu. Now you're back at the regular screen with your backdoor installed. All right. If you are coming up to these, they do have tamper switches in them. Again, your mileage varies about how often those are actually hooked up and they'll alert on you. But if you did have the key and you wanted to open this up, there is a sensor in here that could send out an alert to a team to come respond to it. Here's how you bypass that. So he's going to show on the software, I opened the lid, door was open, door was closed. We have logging and alerting on that. We take our trusty neodymium, smack it on the side without breaking any fingers. And opening and closing now does not generate logs on that system. So we have basically just introduced what the system thinks is another sensor there that provides that field constantly to what's reading if something has departed in the door and provides that signal, that magnetic polarity. I've also printed the 222, 343 keys, rather modeled them. So these are available on my GitHub as well. Freely available, 3D printed keys. That one was tricky to make. It's tricky to print. It's not the ideal stuff you want to use for this sort of thing, but it's really cool that we can have field expedient options where you print a key on site if you needed it, or just be able to model and like have that stuff to be able to reference and cut keys from that. But it is effective. One of the hardest parts that I found to it on your key blade, obviously the thickness of the key, looking at the other side of that profile is super thin. So when you try turning that can get broken off in the keyway. Also, a fumble, really, if you had to talk and confront somebody and have to dig that key back out of there. So I was experimenting with things like how you introduce a turning tool into this at the same time. So I think I do have a model that has it cut out so you can slide the turning tool in at the same time, slide the key in, separate the pins, make the shear line, turning tool to actually apply the rotational force. And that held up pretty well. So magnets are super cool. Also bipolar sometimes. So this is in a facility where varying access throughout the day. We could gain access to one of the exterior egress stairwell doors. It did have an alarm on it, but the idea was we'll disable the alarm, come back at night, and then pick our way into this door. You never want to fully render something inoperable. I hate disabling or circumventing alarms on the exterior. That always needs to be discussed with the client. We can't come onto a site and introduce vulnerabilities for us to be able to get in, because then somebody else can leverage that. So typically this looks like, this is our situation, this is our one door, we want to test this, it's up to you, here's the risk associated, but what we generally recommend is we'll compromise this door and we'll stake out in the car and have eyes on it 24/7 while that's in a vulnerable state. So while this alarm's disabled, still the door will need to be picked. So if you have a really good barrier there, is the only reason I want to do that on the exterior door, rather than taping latches or something. That would be a bit more verboten. Can't discuss with client rules and engagements, always vary, but that does carry more risk. So there are things about being a good security practitioner, especially physical. You can't introduce vulnerabilities, especially on the outside, that other people could leverage. But the moral of the story is magnet alarms can still narc on you. So if you don't get the polarity right, I slapped the magnet on that one to the point where it adhered to the metal. But that was in the reverse polarity of that alarm system, so that started alarming. Fortunately, that's like a localized audible alarm, doesn't hook up to anything, so we were okay, just snapping that back off. And we dealt with that later that night. That was a fun night. This is your magnetic probe, so it's just basically a magnet on a 2-axis swivel, so you can start tracing this around the edge of the door from the outside and detect that polarity. If you have access to the sensor, you can go up to the sensor and see which way it wants to receive that magnetic field. And if you're congruent with that, then it's not going to. Okay, lightning round. How are we doing on time? Yeah, it flies. Door bypasses. Typically, most facilities, if you walk around, you enumerate things thoroughly, just like cybersecurity, full enumeration reconnaissance is the first step. There's a good chance you're going to come across something like this. A door propped open. This happens all the time, even at high security facilities. And the client will beg and plead and swear to you that this was the one day this has ever happened. And that always seems to be the one day that I'm on site. Which is, kind of speaks volumes. For a while there, we were always, man, we're getting so lucky on all this stuff. We just walk in, doors are open for us. And it really does seem to come down to, like, this is the state of security. Physical security is really overlooked, and people don't understand the relationship. So I have a lot of people outside the community asking, why are there locks at a hacking conference? How does this relate? Well, if you spend $1 billion on your cybersecurity and install all the firewall rules and nobody can get in virtually, what if the door's left open at the back and they can walk in, grab that server and walk out? So physical security, I mean, almost always trumps remote access. So if you have physical power cycle, do admin privileges that you're not able to otherwise, reset, flash firmware on systems, embed hardware persistence. I mean, it really escalates the game. It's probably the most privileged form of compromise that we come across. So going back to our latch bypasses, this is the number one most used technique that we use to blow through buildings. It's pretty much present. I can find this vulnerability almost on any building out there. Even if things appear to be working properly, we'll get into that. But the components in play, this is your latch, right? What's in white there is the primary latch. When you close the door, you have a beveled edge that strikes the strike plate. And so that curved edge to the door closes, that depresses, goes in the strike cavity, and then boom, that primary latch extends in the strike cavity. That's why when you go to the door and pull it, it's that little component dressed in here prevents that mechanism. What should be happening in that situation, you shouldn't be able to go up to that latch then and then just manually retract that. So if we did have tool insertion access, if we could slip in our credit card tool, our hall pass, whatever professional tool that we have to be able to retract that latch, should not be possible if the auxiliary dead latch is working properly. That's the component highlighted in red. This is really difficult to get right. When it does work properly, it's fantastic, but the mechanism works as such. The door closes, primary latch extends in the strike cavity. The auxiliary dead latch needs to rest and remain depressed against the strike plate, right? So you have pushing, pulling motions. One's extending, one has to stay retracted. That's really hard to get right 24/7 in small spaces like that when you deal with lack of maintenance, building settling, improper components being used. You may have electronic strikes like this that already have a little bit of play and wiggle. Even when this is engaged, there's still a little bit of wiggle there. So everything can still be working properly, but if you have a large enough gap, that'll retract a 1/4 inch, and that may be enough to open the door. So to visualize this a little bit further, because again, this is the support hammer, then point home, latch bypassing is the number one exploit that I use on the job. This is how it's supposed to look in a exploded or cutaway view. Latch is extended, auxiliary bolt remains depressed. If you have extra room in here, and again, this is beveled, if you can lean and push up against that door, because this isn't the only component in play, you have the jam, the stop, there may be weather stripping that already provides that cushion. The building may interact differently throughout the day as you have AC pressures that change and close doors differently. So to get that feather just right, even in this example picture, which is a really good example from a manual installation video that I found, even this one, it's only halfway depressed. So if you're off by 1/8, 1/4 of an inch, if you can go up and get that little bit of extra wiggle in the door, push on it, and then that's going to depress the strike cavity. Now it's disengaged. Now the mechanism is vulnerable. So to exploit that, we use tools like a traveler hook on the left. That's probably my favorite because you're able to articulate that a little bit better. If you go in on a single axis, then you can start scraping and wiggling this and start retracting things manually. It gives you a little bit more control. What's field expedient is carrying something that you have on you in your wallet. I never leave home without my hall pass. These tools are fantastic for coming down over the latch. If you pivot up against the tool, it hits the stop, right? And so then this one starts retracting with a lot of mechanical force right where you want it. So that's my technique. You'll see people that come down, they just swipe straight over it. As long as it's catching that beveled edge, mechanically that should retract. Things should stay gritty. You're dealing with a push lock door, right? So it's gonna be fighting you. So you can have grips on things can really help. Again, the traveler hook is very good for that, for the lifting technique where you pivot against the back of the gym. All right. So even if things are like working properly, the internal components to this I found are failing on about like 10% of installations. That have been in the field for maybe 5 years or longer, we'll say about 1 in 10 I found look perfect from the outside. Again, just like hacking, man, unless you've really gone in there and tested and verified for yourself, you can't make those assumptions. So take the door apart, man. Even at Lockpick Villages, we did the fifth site village at DEF CON this year, and half of those locks were already broken on site. We're demonstrating like flash bypasses anyway, so cool, they were really easy to get open. But I wasn't able to demonstrate, I had like one working one where I could actually show how that mechanism is supposed to work. Most people don't know how that works. In fact, I come on site and I see this semi-often as well, where I can't say locksmith, but the maintenance worker or installation tech has come by. And on this one, they actually drilled out the strike plate so that second component could depress and fall into there, which isn't supposed to happen, but they made room for it and made it vulnerable for not understanding how the lock works. If you see gaps like that, that's just juice. Your mouth should be watering. You can visually identify if we're in a secure state or insecure. This has so much of a gap that only a little bit of that tip of the latch is biting into that strike plate anyways. So even if this is engaged, there's still that play that may be a little not as it were. That one just demonstrating the video we'll skip over, but if you push that, both of them still depress. So mitigations versus remediations. Remediation fixes the issue. Mitigation kind of reduces your risk. This is a latch guard. This isn't just for bypassing. This is a lot of times for destructive entry as well. This prevents access to those vulnerable mechanisms where if you did have an angle grinder, you just hit that latch and then you're in. This helps prevent that, but also helps prevent tool insertion, right? However, this doesn't fix the underlying vulnerability if that latch is vulnerable. I think that's all we're getting into there. So some professional commercial tools, firefighters are great at this. So there's a lot of work done in that industry. We're kind of parallel. They call it exigent entry or respectful entry. The purpose here is maybe you need to get into somebody, they've fallen, but you don't want to make their day worse and break down their door and slap them with a $10,000 repair bill on top of their $1 million medical bill as well. So you try to bypass things, you can do it quickly. So firefighters have gotten really good at this and they came up with commercial tools like that hook, kind of looks like a scythe that goes around that. We can use field expedient things like guitar wire, piano wire, anything that has that little bit of memory to it where it's going to stay curled, because what you need to do is throw this over this the lash guard and have it curl back to you underneath on the bottom, which is what this gentleman's demonstrating there. And this is part of a firefighter training video. This is a slide. There's a missing slide where these guys, again, field expedient, used Cat5 cable. I'm sure Cat6 would work as well. But they just threw that over for a bank that I previously broke into the previous year. They spent great efforts going through remediating everything, and then these guys found a different method of entry, which kind of goes into red teaming and some of the purposes. It's great real life examples of how things can be compromised. It can train the people, it gets them inoculated to like, hey, I got social engineered. It's that live fire exercise that you don't get anywhere else. The drawbacks to it are typically you'll see a single path of compromise, and if you have a large enough building, like a campus, there may be other methods that aren't able to be enumerated on this attack. So still trade-offs. If you get that report as the client, still need to go through every door and investigate things to make sure those vulnerabilities don't exist elsewhere. There's also the chance that vulnerabilities exist that team didn't identify, that didn't come up in a report, that still exists elsewhere in the facility. So I try to preach to clients when you're first getting this kind of work done, try to do a whitelisted audit approach. So we started doing that, had amazing success. We would meet with clients, go over a presentation much like this, and then we walk through the entire facility. We check every single door. We check security configurations, camera layouts, RFID. We dig a little bit deeper and give them the best fighting chance. So again, that concept of almost like a code review, having all the information available to you to then be able to get the full picture and defend things better than an attacker who's only going to have limited time, resources, and ability to interact with that stuff. All right, so I love sparrows and not gonna talk shit on that. They're an amazing company. They do get a little overhyped, acts like they cure cancer, that, I love the smoke and everything, super cool, but it's, kind of pumps the gas. Yeah, that's right, yeah, gotta keep the lights on, celluloid, those are celluloid shims. Those have been around for decades, but varying thicknesses, and those let you curve around gaps. So when we're using that metal bypass hall pass or the trap so that's when you have direct line of sight. So you know based off the swing of the door, you have outward swinging and inward swinging. You're gonna have direct line of sight. If it's an outward swinging pulls towards your door, then you can see that latch right there, door opens. You may have some other stuff that's recessed. So this is also outward swinging doors that use a Von Neumann crash bar mechanism, which can remain recessed. It's on the inside of the door, on the inside of the jamb, and to get around that, there's basically two 90-degree turns. That's where you need flexible pieces. You can't just use straight stock metal. So material science always comes into play. We try to get the strongest materials that are flexible, that can't break. I mean, to try to fit everything, there's no single solutions. You have to have a lot of tools in your arsenal to be able to snake around things like that. What we've ended up using with great success are these thin, flexible cutting mats that you can buy on Amazon. These are flexible cutting boards. But if you strike a notch into it towards the end, what we're going to do, that my partner in crime here is demonstrating here, we have the notch cut out. We're sliding this through the door. We're snaking around those 90-degree turns, going above the latch. So we're not directly interacting with it because if we know how this door closes, we understand where that latch has the face. The beveled edge is away from us. We'd be poking at the flat side. That makes sense, right? So the door close always has to meet the beveled edge. You understand the internal mechanisms. You can't see them. So we go over the latch with that notch cut out. Then we start pushing past it, coming down. Okay, now we found the latch. So our board is sitting on top, the latch is here. With that downward pressure, we keep dragging back, boom, until we find that notch. We'll feel our board drop down, and now we know the latch is contained within our cutout. And now when we start pulling, we're interacting on that latch to retract it. Again, only possible if that door is in a vulnerable state. How do you remediate this properly? I think the best mechanism that I've seen is an offset auxiliary dead latch. So kind of hard to see. This is the crash bar mechanism. This is the primary latch. This works pretty differently than most doors we see around campus. I think they do have this where it's not in line with the primary latch. It's offset vertically. And this is so much easier to get right because rather than having to play where you come back and forward and maybe that can push in the strike cavity, if you sit this offset, you can just have flat metal all the way through, and that will remain depressed. It's a more secure implementation. Still, you may have the internal components fail. There's still opportunities there, and you may have to investigate. So we're going to go into an electric strike bypass. This was super cool. Probably one of the most secure facilities I've ever tested were cheese packing facilities. Not the NSA, not high grade military institutions, but cheese packing. And the idea was, the head guy for security, which was also about the only guy, his grandfather was a locksmith. And this man went around and understood these principles and was able to really secure his facility probably better than anything we've ever seen. This was the only man who challenged me when I'd come on site after hiring, like working at coal fire for a decade. We go on site to this guy and, he's contacted us through the company. The man checked my socials. He's bringing up, like, just laying down threads like, hey man, did that really happen like the other day when we posted about this? I'm like, yeah, but he's like vetting me, making sure we're the right people to enter his cheese facility. So it's the most stolen food, so maybe he's valid with that. Anybody know the most stolen book? The Bible. Yeah, you got it from the hotel. That's right. That's why you never see them anymore. Okay, so I'm going to show that one more time. What we're doing here. This is the reader that we had hanging, and there's an electric strike, right? So you come up, present RFID credentials, and back end, a lot of stuff happens, but it talks and eventually pushes out power to the strike, and that's what enables the door to open. Here, they basically bridged, they had both connections in this outside junction or access box. So by taking that off, we can see the lines going into the reader, as well as the lines going into the strike plate, and it would just bridge the power from the reader over to the strike. That engaged the strike and allowed us to open the door. And that was actually the client doing that, which is really bad. And like this was the most secure room. Within it had all the records. Everything's just sealed up concrete. There was like very few other ways to get into that room other than that bypass that he came up with, which was pretty cool. RFID, so typically we're talking about things how, there's two states, we can fail open or we'll fail safe and we can fail secure or fail closed. This shouldn't really ever happen. I've talked to a lot of people about this, but it did happen, so I try to bring it up and let you know. I took a reader off one time and disabled power to it, and that either disabled power to like a normally closed stripe and it opened up. So again, shouldn't be the case, but by killing power to the reader, it actually disengaged the locking mechanism. Again, this is like kind of edge case. 1% of installations may be susceptible to something like that if they took shortcuts, but it can happen even if it's not supposed to. So we also have RFID implants. A lot of the older readers now, and still you'll see them like physical security is pretty stagnant. It doesn't update with time as much as cybersecurity does. And stuff costs tens of hundreds of thousands of dollars to out an entire facility, so you'll see stuff in the field for decades. That is the case with RFID. That historically used the Wynn protocol, which is clear text on the back end, so the communication between the reader and the controller, which then sends the signal back down to the door to strike. That could be intercepted. So if you install this little implant called a bleed key, basically we're using vampire taps. We have a chip, that's programmed to intercept Wynn. Well, we punch down power, data, ground to this, and then seal everything back up. Now we have a man in the middle attack. So when credentials are presented, they fly over the wire in clear text over our tool that intercepts them. We can interact with this. This one's from Bluetooth. You have a Wi-Fi. You go and plug into it. How do you do it? Access that chip and then just say, you play with those credentials, send that over the wire jump. So there he's valid credentials for the first time. Now he's connecting to this bleed key over Bluetooth. Now he's looking for cards or credentials that were swiped. And we just said, replay that card that was previously presented, sends over the same clear text credentials, and opens right up. This has been remediated with newer protocols, and we're seeing this now and come across it quite a bit in iClouds and there's great things that can remediate, prevent attacks like this. But man, you'll even see stuff like biometric scanners in airports that use retina scans or fingerprints in combination with multi-factor authentication to present your card credentials and a keypad. All that can still go over weekend, all over clear text. So I mean, without doing anything different, just replay that thread and you're in.
No, I was just, sorry.
Oh, okay, all right, cool. Collaborative. Shit. So cloning also is the other component of this. So we can attack the reader and attack those communications that go over clear text on the back end. We can also try to clone credentials, which again isn't the case nowadays all the time. This is more common to see higher security protocols on the cards themselves, where they're not as easily cloned like this. I think this is, the higher market share. It's a lot easier to clone things from a distance rather than getting up close and personal and installing implants. So I think they're tackling things, as well as you can and prioritize it. But some cards can still be, powered up remotely. This is induction, right? So you have your antenna in a long range reader such as this, and it throws out power and it lights up the circuit inside your card and then throws back credentials, which are captured and read on this device. Time. Okay, 5 minutes. All right. I don't think there's a talk after. There is. There is. Yeah. Oh, okay. All right. We'll wrap this. Thank you. All right. We're really gonna go lightning round. Another round is 57 of 86. We're doing great. We got this. 4 minutes. Yeah. Door bypass. You have thumb turn tools. So we have something called like a J hook like this that can go around that thumb turn. And again, tool insertion to a sanitized, trusted side, right? There's privileged access for somebody that may need to egress or just convenience, locking the place up at night. That tool can go over and attack it. What I recommend, the tip for this, hook bolts that swing up like this tool is in the wrong position. We're just like showing the camera. You want to come over top so the bar of your tool doesn't intersect or conflict with that path of travel and block you from opening that. Air wedges are really great. I try not to use crowbars too much. They're more effective, but also more damaging. Air wedges are pretty benign.
I used one of those and I locked myself out of the car.
Yeah, no, exactly. Like that's probably more common where you see that stuff. And still, you can bend things. I don't know if you have a whistle in your car now, but we do have to worry about that kind of stuff on client sites or glass like that.
What was crazy was the gas station right on the interstate sold like a
break into your car kit. Because it was like they knew that worked.
All right, hey, man, snag some extra dollars is the bottom line. I keep one in my car.
Being cold, it's stuck, very good motivator to learn that thing.
I believe it. All right, I'm gonna rip through the rest of this real quick, because this is the second most common bypass that we use. This is an under the door tool. This is used to actuate levers on the trusted sanitized side of the door. How this works is you slide it underneath the door, hit it back up, kind of smack the door and slide it over till you reach that handle. And you still have your cord on the other side, so you can pull down on that tool and it pulls down on the lever on the opposite side. So if you come across something like this, great, mouth is water, you can slip anything underneath that, bypass this. I love the handles that have that curved hook at the end, so your tool doesn't slide off. UDT accessories, you can slip your phone camera through with the reverse, take a video, see what hardware you're working with. Borescopes are also really handy to use. You can modify some of this stuff on the ends to be able to slip around crash bars. So this is now just a hook that will clamp down back there, pull the line. This used to be a non-commercial tool, which they now commercialized by Corporate Instruments, called the grappling hook, and this lets us actuate handles where otherwise the tool would just slide right off. Super handy, a little bit tricky. It's also working on like a different axis, so once that goes over the handle, you may get stuck on there and you have no choice but to open the door. The one by Corporate Instruments is great because it folds, wraps up. They also have concealment versions like that can hide in the belt. To remediate this, my favorite method is a ragged threshold that prevents tool insertion. You know, next people out there, I don't want to prevent them from coming in.
Yeah, there was an issue, there is one starting in a couple minutes, so if you.
Okay.
Yeah,
Okay, are they ready? Are they out there?
yeah,
Okay, I don't want to hold them up. Great, man. All right. All this great content there, we're gonna have to do a bit of time. Final slide, there's feedback here. This is the first time I've given this talk. Obviously, we didn't nail the slides, but if you guys want to make a shift to our notes, would really appreciate your feedback. Let me know what's like when we change on this. So thanks for your time, guys.
You say, one of the things I noticed with those, the pin code box, they're starting to change those out with these like, newer